Yesterday, on page 7 in our book, we went through here and I modeled for you Stella, all right? We took the minutes that they traveled. All right? Need your attention. We took the minutes we traveled, we plugged it in, and we found the actual or the predicted values over here. Then we compared them in our book. We compared them to the actual values, and we came up with the difference. All right? What did we call that yesterday? What was the difference called?
The
Residuals. That's correct. Okay? The residuals. Okay? So we found the residuals. Now, there may be a time where you may take a test or whatever in class. You come back the next day, teacher graded or whatever, and they said, hey, the class average was 80. All right? So what do you immediately do? You check your score and you go, how did I do versus the average, right? So that's kind of what we're doing here. We're checking our model that we have, and we're checking it against the actual distance, and we're finding the difference, and we're finding those residuals, okay? Now, I asked you to do that for homework last night. I gave half the class one, and I gave half the class the other. So this half of the class, I asked you to go plug into Jasmine's equation, and then go get me those values, and then go find the residuals, okay? I can help you with the residuals, but you need to help me with the values. So if you did not do Jasmine last night, then you're writing Jasmine's down as we're going, okay? And so the first one, when you plug in 30, what did you get? Okay, 29 point, I'm going to go around it to one decimal, I'm going to go to 29.9, okay? So 29.9 for the first one. When I plugged in 62, I got 64.77. We'll call that 64.8. These are Jasmine's, okay? So, because you probably did Brady, and so now we're doing Jasmine. That way you get it written down, all right? The next one. 89.8. Next one. 132.4. 161.0. 161 what? 0.8. Okay. And 198.8. Okay. So again, where are these coming from? I'm taking the 30, the 62, the 85, the 124. I'm taking these values. I'm plugging them into X, and this is what I got. Okay. These are my predicted values. I want to compare my predicted values versus the actual amounts over here. Okay? So if I do predicted minus actual, then this is a negative 0.1. If I do 64.8 minus the 65, that's negative 0.2. If I do 89.2 minus that, that is 12.2. Is that right? Am I do that one? Yeah. I think that's correct. 12.2. If I do 132.4 minus that, I get 2.4. If I do 161.8 minus that, I get negative 3.2. And then this would be 8.8. Okay? These are my residuals that I just found. Okay? If you notice, the first two are negative 0.1 and negative 0.2. Is that pretty close? Yeah. That's not very far off. Why did we say, what did we talk about how she came up with her model yesterday? She used the slope between this point and this point. So if I use those points, wouldn't those be pretty accurate to my actual? All right? So that's what we're seeing. But we see 12.2, that's pretty far off. We see 8.8, that's pretty far off. Those are these right here. All right? So that's what's taking place. So I'm looking at, if I'm negative, I'm underneath. If If I'm positive, I should be above. Okay? So my model, if my model is there, all right? This one should be negative, shouldn't it? Okay. That one should be negative because my model is underneath my actual. So that should have been negative 12.2. Sorry, I missed that from a while ago. All right? Yes.
Like, could you add up all the residuals and then like divide them by 6 and then figure out the average?
We could. We could. That would be a pretty good deal. So I could do that, right? I could maybe. So let's come back to that. Hold that thought. All right. Let me go do Brady. That's a good thought you had there. Okay. So let's go to the other side. So now, if you're on this side of the room, all right, you're writing this down because they did this for homework last night. All right. And so let's go put Brady's in. So what did you get for the first one?
Yo.
Crickets? Nobody?
Yo.
Holy bum.
You get it? All right. Here you go. Then let's do it real quick. All right. So 1.03 times 30. That's what we're doing. So use your calculator or whatever. All right. So if I go 1.03 times 30, I got 30.9. Okay. 1.03 times 62, I got 63.9. 1.03 times 85, got 87.6. I'm rounding to the nearest whole number. Okay, I mean there's 10th. Okay. 1.02 or 3, excuse me, times 121. Excuse me, that should be 121. That should be 124. 124. So that's 127.7. To do that again, 1.03 times 151. So it's 155.5. And 1.03 times 185. So I got 190.6. Okay? Could have done that on your phone. You did not need a calculator at the house to do that. Okay? Now I'm going to compare. I'm going to compare my actual versus my, my predicted versus my actual. So predicted minus actual. So this would be 0.9 would be that residual. 63.9 minus 65, or 60, yeah, 6 probably. All right, minus 65 is a negative 1.1. Okay. 87.9 minus the 102, 14.4. It's negative 14.4. Okay. 127. Negative 2.3, yeah, okay. 165, negative 9.5, good. And then point what? Okay, because it's almost on, right? It's a 0.6 or 0.55, yeah, okay. Very nice. All right, so there's that. Now, do we have some really concrete evidence on how good a model was or how it wasn't? We had to do a little bit of work, right? But we have these residuals. Now we can compare how good the model is. Because that's where this all stemmed from yesterday, is we just looked at the model. We made some kind of conjectures and stuff. We talked about them to see who was better, who wasn't as good, all right? Now, Bobby threw out an idea. He said, well, what if we took up all the residuals and divided by 6, and we got an average of residual? Would that be a good thing? Would that be a good way to compare them? Yeah. It might be a pretty good way to compare them, right? Who had the best average of residuals, all right? That might not be a bad idea. Now, let me ask this. Can I add up all this error? Could I go through here? Now, this one's a little bit different because where's a lot of the error here? They're all negatives, so my model's going below the actual. So that's probably not real good, all right? If I went to this one here, what would happen if I took the 2.4, the 8.8, and the negative 12 and add those together?
Probably balance like maybe zero.
Almost balancing out, right? If I have a negative 5 and a positive 5 and I add that together, then I get 0, right? Now, what is residual standing for in this problem?
The difference.
It's the difference. It's how far off I am. It's my error. Okay, I missed. How bad did I miss? Well, if I missed by 5 and if I undershot by 5 and then I overshot by 5 and I add those together, then I can say I didn't miss. Is that a true statement?
No.
No. I really had error, but it's being hidden because I'm adding positive and negatives and they're canceling each other out. So that wouldn't be a good thing. So somehow we need to be able to go through here and be able to find the error and see which one had the most error, which one had the least amount of error, okay? How could you go through here with these residuals right here? How could you go through and make them all positive? Absolute value. That wouldn't be a bad idea, all right? Good. There's another way that I was thinking about, and there's another way that this works this. Oh, I thought you were raising your hand, okay? What other function could I do that would make it positive? If I go through here and square them all. If I go through and square them all, now they're all positive. Because you take a negative times a negative, it's going to be positive. If you take a positive times positive, it's going to be a positive. So now I could square them all. Now, am I over inflating my error though? A little bit, but at least it's all going to be positive. So now I can add up all this error after I square them, add up all this error, do the one that we did yesterday, and I can see which one had the least amount of error. And I say, that's the best one. Make sense? That's exactly what running a regression is doing. Here's what I want to do. We're going to take a moment. I want you to go to a Schoology. All right. Hopefully you've got that pulled up. I'm going to go to my Schoology so I can show you. All right. So let's go to Schoology. I put a link in here for you. All right. The link I put in here is the sum of least squares. So you're clicking on that link right there. I would probably take it out of Schoology. I'd use my little box with an error, and I would take that out so that I have this. Now, don't do anything to it yet, okay? Most of us are close to getting there, okay? No, we're in Schoology. All right. So here's what's going on. Let me explain to you what's going on while the rest of us are kind of getting there. All right? These green points right here, these are your data points. Okay? The green points are the data points. They're the ones that were in my table. Okay? Now, the black points I'm going to be able to move. All right? So I'm going to be able to move this, and it's going to change some things here in a second. Okay? But before I get there, I want to talk about the boxes. We've got these squares here. Okay? I have this red line on the left-hand side of this square, okay? What does that red line represent? That we were just talking about. That is the residual. The red line is the residual, okay? So the red line is telling me how far am I off. I'm making this model right here. How far off am I from my green points, okay? So the red line is the residual. Why do I have a box on there? It's not a box, it's a square, by the way. What did we do with all the residuals? We squared them all right? You see it? So what we're seeing is we're seeing these squares on here. Now what I want you to do is I want you to just kind of work with the model, all right? Move your points and see if you can get the least amount of sum on there. See if you can get the lowest sum. Move the black points. Don't move the squares, move the black points. You might kill that one and go back to the Schoology. Or that's fine too. So you're moving the black point. See how low of a number you can get. Okay. Moving to see who can get the smallest number of squares.
No, it's gonna move the box itself.
You can move either one of them, either of the two black points. Yeah, you can move both of the black points. Get to where you can get the smallest.
I got it to 320. Try hard.
Ooh. I got mine to 9.
What?
Oh my gosh, it's still at 600. Wait, it went to 81, so I got.
I got a 193. Huh? I didn't move the boxes. All moving is the two black points. Okay? So basically what I'm doing is I'm trying to make my model. So,
36.
all right. Now, do you see what we're trying to do here? What's happening with all my boxes? What's happening with all my squares? I'm getting smaller. So when you clicked on the link said the sum of the least amount of squares. All right? So I'm trying to find the sum of the least. What if I had you do this by hand? What if I had you square all those and add them up or whatever, and then go test a different model and go test a different model until you found the one that's got the smallest number of squares? You probably would not like me very much, okay? But that's exactly what the calculator is doing every time that you run the regression. It's doing this. It's taking points, it's moving it around, and it's finding the one that's got the least amount of squares on it, okay? And it's saying that's the best model. Does it make sense? Do you appreciate what the calculator is doing now? Okay? Because I definitely would not want to do that by hand either, okay? And so what's taking place, Stella probably would have had the better equation that we talked about yesterday. Stella would have had the better one because it was actually the regression model, and the calculator did this for me, and so it would have the least sum of squares. We didn't actually add them all up and do it, but if we had squared them all and add them all together, it would have had the lowest sum that we could have. Okay? Good? So you kind of understand what's going on there. Now, we're going to kind of go to a little something different now. So let's go to page, I believe it's page 9. All right, so turn the page. Let's go to page 9. Okay? We're going to do a couple little data plots here as we're going. All right? So on page 9, I'm going to start off in Desmos. I'm going to walk you through this in Desmos, and then I'm going to do one in the calculator with you as well. So it says this: for each of the following data sets, we want to use a graphing utility, so we're going to use Desmos to start, to construct a scatter plot. Did we do that yesterday? Yep. Can we determine the linear regression equation? Yeah, we did that yesterday as well. All right. And then we want to construct a residual plot. That's the new piece that we're going to talk about today. Then use that plot to answer if this is an appropriate model or not. So here we go. So I'm going to go to my Desmos. So I'm going to Google. I'm going to go open, and I'm going to do Desmos. I'm going to do my graphing calculator. All right. How do I put my table into my Desmos?
Plus.
The plus sign. I get a couple options. The option I want is the table. All right. The nice thing about this is as I start typing 1, 2, it goes, oh, you've got a pattern, 3, and I'm just hitting enter, and it does it for me. So I go to 10. So 1 through 10. All right. Then I'm going to go back and I'm going to put my y's in. So 2.3, 2.7, 3.1, 3.5, 3.9. Okay. So I've put my X's in, I've put my Y's in. All right. Has this already kind of created a scatter plot for me?
Yes.
Yeah. Did anybody hit zoom fit? Did it help if I hit zoom fit?
Yeah.
It helps a little bit, okay? So we talked about zoom fit yesterday over here in the bottom left. So I hit that, all right? It kind of does that for me there. I didn't talk about this yesterday, but if you just click on the graph and drag it, then you can get more things that you want as well. So if you want to just move it that way, you can, okay? All right, so we got the scatter plot. By the way, looking at the scatter plot, does a linear model look appropriate?
Yeah.
Looks pretty good, right? So we did that a couple days ago when we were looking at that, trying to figure that out. Now, the next thing it asks me is it says, okay, write the regression model for me. Okay? Where are we going to do that? The top left, yes, right there. And we write the equation. So going to write this equation in your book. All right, so on this problem, I'm going to write y equals 0.4x plus 1.9. So my model here is y equals 0.4x plus 1.9. So that's the model. I'm trying to decide if it is a good model or not. Okay? So that's the model for this data set. Now, I want you to bring your attention to a couple other things down here by the linear regression. We have this R value. It's called our correlation coefficient. The R value, if it's equal to 1, then it means it's perfect. It means it's hitting every single point. Does that look like the case here? It does, all right? This is like saying 100%, okay? So this is kind of a percentage if you move it to the decimal place to the right. Now, beside that, you have a thing that says residuals. It was there yesterday, but we hadn't talked about residuals, all right? Now that we have, it says, oh, you want to plot them? And I'm going to hit plot, and it's going to plot my residuals for me. Okay? Now, the first question on your page says, describe your residual plot. So what would you say right here? My residuals are plotted in red up here. So how would you describe the residual plot? What would you say? They're all x-intercepts, right? What did you say?
Zero.
They're all zeros, right? All the residuals are zeros. It's figuring out how far away from the line those are. So they're all zeros. They make a horizontal line. Okay? So that's what we're going to say here. And so when we're describing this residual plot, we'd say they're all x-intercepts is what it looks like. The value of the residuals is 0. Residuals are all 0. We'd say it makes a horizontal line. So those are kind of some of the characteristics or descriptions we could say about the residual plot. Now, do you think this model is an appropriate model? Yeah, it's really pretty good, right? Not only was the R 1, but all my residuals are 0, so my model is exactly predicting what the actual is. Like it's on 100%. Okay?
Is that because the constant rate change is 0.4?
Yeah. So you notice that in it has a constant rate change of 4 all the way through it, didn't it? Okay? And so it was set up kind of that way. So yes, it's appropriate. Yes, it's appropriate. You could say all the residuals are 0. All right? Which means my model is predicting exactly what my actual is. So that's that there. Okay? Everybody all right with that one? Page 9. Good? All right. We're going to turn the page. We're going to repeat it again. All right? We're going to do a different set of data. All right? So let's turn to page 10. We have a second data set. I'm going to do this one in Desmos again as well with you. All right? So if it's me, all right, I'm probably going to go up here to my table. If you keep going, it's going to get really crowded over here. I'm just going to go hit the X, and I'm going to get rid of that so I can start fresh, okay? So I'm going to hit the plus sign again. I'm going to go hit table again, and I'm going to start finding my points. Just got my X's in. Right, I can't really see my points on this one, so I'm going to go and hit zoom fit. Okay. So when I hit zoom fit, I get this. Just your first inclination on this when we're looking at it. Is it linear?
No.
Looks more exponential. I would agree with that. It looks kind of a little bit more exponential. Linear doesn't look like a great model here. All right. And so, but I am going to go in and find the regression because that's what it asked me to do. All right. So if I find the linear regression, my linear regression is here. I'm going to scroll down so I can see it. So y equals 6.81 and negative 11.1. All right. So y equals 6.81x minus 11.1. So there's my model. Trying to see if my model is good or not. Now, there's a couple things I want to look at here. Okay? If I look at my correlation coefficient, my R value, is that good or bad?
Bad.
0.977. Think of it as terms of percentage. 97.7%.
Good.
You good at making 97 on a test? I am. All right. I think that's pretty good. So this tells me it looks like it's pretty good. Now, although when we look at it, it doesn't look very good. So we kind of got conflicting views here. I'm going to look at the residuals as well. So I'm going to go in and plot the residuals. Okay. First thing it says now is describe the residual plot. What do you see here on the residual plot? They go down, all right? And then what? They kind of go back up, right? So are they creating a pattern? They're creating a pattern other than a horizontal line, all right? Kind of looks like a U-shaped pattern here, all right? What would you say about some of the residuals? Some of them are above, then some below, and then some above again, all right? So on this pattern here, it's underestimating the first little bit, then it's overestimating all the ones in the middle, then it looks like it's going to underestimate the ones at the end. So it's kind of got a pattern going on here. It's not just random either, okay? It's okay to have residual like one above, one below, and just kind of going back and forth, or I'm kind of hovering around the line. But this one's got a true pattern to it. And so what I would say here is I'd say it's a U shape. It's got a U-shaped pattern. We do have some above. We have some below. All right? But because of this pattern, because of what's going on here, all right, we're going to say that this is not an appropriate graph. Okay? It underestimates early, it overestimates, and it doesn't really go back and forth. It's got a true pattern to this. So this is not a good, not appropriate model here. So the equation that we wrote down above, the 6.81x minus 11.1, that's not an appropriate model. Everybody okay with that? It's making a pattern. We don't want a U-shaped pattern in this. All right. We can see that it doesn't really match very well. All right. But we don't really want any pattern in our residuals other than a horizontal line. Okay. It can be random, but we don't want a U-shaped pattern. Okay. Now, we've done 2 in Desmos. I want to show you at least 1 in the calculator. I know most of you like Desmos anyways, but we need to look at the calculator real quick. So I'm going to go to my calculator, and I'm going to put page 11 into my calculator. All right, so I'm going to go on, and I'm going to go new. All right, yours may be in there already, but I want you to start fresh so that you know how to handle it. So on new, and we're not going to save. Okay, so you got your calculator in your hand. Let's work. Yesterday we talked about putting the data into the calculator. Where did we go to put the data in the calculator? Lists and spreadsheets. Okay. Now I'm going to go up here, and I've got to label the top. So that's X and that's Y, which is good because that's kind of matches what's on my table anyways. Okay. I'm going to go right here to this one, and I'm going to start typing. Again, the X values are easy. 1, 2, 3, all the way down. Once I have the X values in, then I'm going to go back and I'm going to put the Y values in. I think we're getting pretty close. The number clicking is getting a little bit quieter. Okay. Now, the first thing it asked me to do on this one is to go show a scatter plot. So how do I show the scatter plot in my calculator? Control doc to add a page. The page we want where the scatter plot is? Data statistics, good. Go down here to the bottom and click, and we're going to say that that's X. So it kind of regroups a little bit for me, and then I'm going to say this is Y. Okay? So there is my scatter plot. Now, where do you think you're right now as far as the function? It's probably exponential, right? It's probably not linear, okay? Now, we're going to run a linear regression first because that's what we're talking about. Talking about linears, all right? Now, here's what I want to show you next. Now, you probably missed this when we were talking about this the other day because you were focused on something else. But if I go to Menu and I go to Analyze, then what do you notice on number 7?
You got to do the regression first.
There's the residuals, right? But it's grayed out. So you're right. I have to go do the regression first. So I can't find the residuals until I run the regression first. Okay? So I'm going to go run the regression. I'm going to go do linear. And there is my model. Now, by the way, that doesn't look very good, does it? No. Okay? It looks like it misses a lot of the points. It doesn't look very good. So my model, I'm going to write my model down. It's 2.40x and negative 6.81. All right? So I'm going to take that and I'm going to write that over here. All right? So it was y equals 2.40x and negative 6.81. All right? That's the model that's in question. Now, we just talked, we said, all right, so we've run the regression, and we said, well, the residuals was in there, but I can't get to the regression, the residuals until I run the regression. Now if you go back, you see, oh, now I can click on the residuals, all right? If I click on the residuals, it gives me 2 options. Do you want to show the residual squares, or do you want to show the residual plot? Well, the residual squares, if I click that, that's kind of the activity that we did a while ago. Now, you don't get to move these around like we did. But you notice we got big squares here. We got a really big square at the end. It's kind of maybe cool to see that. Some of you are going, no, I don't want to see the squares. If you don't want to see the squares, that's fine. Go back to Menu, go back to Analyze, go to Residuals, and say, go hide those squares. Okay? So it's going to hide them again. If I go Menu, analyze, and residuals, and it's really the residual plot that I want. When I do this, it creates like a split screen for me. Okay? Here's my original stuff, and here is my residual plot. What do you notice about the residual plot? How would you describe it? It's that U shape again. It goes down, it goes back up, all right? It's got some above and some below, but they're not like alternating, okay? And so, what would you say about the appropriateness of this model? It's not. That's right, okay? It's not appropriate. So this one was very similar to that last one. I'd say it's got a U-shaped plot. U-shaped plot, so we'd say that the appropriate is, the model is not appropriate. Okay? Everybody okay with that? Is it okay for them to be above and below? Sure, all right? But we just don't want a pattern where it looks like a U. So if they're hovering around the x-axis and it got some above and some below, then that's okay, all right? So it's not, it still can be appropriate and not be perfect, all right? So here's what I want you to do. You've got about 9 minutes left. We're going to do page 12 and page 13, all right? There's two more data charts. Page 12, page 13. You may use your Desmos, you may use your calculator. I don't care which way you do it, all right? But that's what we're working on. I'm going to give you the rest of the time to work. If you don't finish, then that is the finish at the house, okay? So we're doing page 12 and page 13, all right? Use your Desmos or use your calculator. Either way.